Hello. So I welcome you to today's training about thermal cameras. Today we will learn something about our thermal solution for both perimeter protection and fire prevention. So in the beginning, you can see that there is a QR code you can use in your DH Partner app, and you can use it to scan and to get 50 points. So there will be this QR code at the end of the presentation as well, so you will not miss it. My name is Martin. I'm from the Czech pre-sales team, and I guess let's get to it. You can also win five cameras during the training. So you will see the prompt that there will be a question that you can answer in the comments. So the first one to correctly answer the question will get the prize. There will be also some guidelines on the end. You have to take a screenshot of your correct question or answer and send it to us. So if you answer correctly, save your answer like a screenshot or take a photo and send it to us. There will be instruction at the end. So let's get to it. We will start by learning about the thermal product family. So we have a couple of series of cameras for various purposes. The lowest series, the first series, we have the basic cameras. Oh, sorry, you don't see the presentation. Oh, my bad. So, my bad. I will return back to the QR code, like so. I'm sorry. You can see the QR code now, and if you have time to take a screenshot or to scan it, I will give you some time for now. But at the end, there will be the same view also, so you will not miss out. So let's get to it. Okay, so let's get to what we are learning today. So first, there will be like the thermal product family introduction. Second, I will teach you and show you some videos and functions about the perimeter protection. And then we will continue with fire prevention, so temperature monitoring, smoke detection, stuff like that. We will also take a look at some success cases, because we have many success cases, to be honest. And also, I mention again, you can win the camera by answering correctly. The questions are not hard, so the first one to be the fastest will win the camera. So we have many series. This series, basically the most commonly used, I would say, is a two series. One series and 5 series. It differs, of course, with the price and also with the functions. So usually the better series, the better camera. This is an example, as you can see this is an example of the 5 series camera, and this is an example of the 1 series camera. So these are the most commonly used for functions like some simple perimeter protection, or even with the 5 series more advanced perimeter protection, and also thermal monitoring. Because we have two basic difference between the usage of the cameras. You can see the T in the presentation. You can see the T letter at the end, which means the camera is used for measuring temperature and fire prevention. So if you see the same models, you see the T at the end, it's for the temperature monitoring. If you don't see the T, it's usually for perimeter protection. As you can see, the 8 series and above, the Ultra series, it's usually PTZ cameras and positioning system. It's usually for bigger distances, for perimeter protection, such as airports, deserts, some coastal areas, so some specific installation. But the PTZ cameras, it doesn't matter that much about the distance. It can be very useful even at close distance. We will get into PTZ cameras later, though. Yeah, so there are some like various usage for the cameras. you can see the approximate distance of the functions. So you can imagine like the 1 series, 2 series cameras, they are for the closer distance, they usually have smaller resolution. But the better cameras, the more pricier cameras, it's usually bigger distance, bigger resolutions, and of course bigger like areas that we can cover. So for simple perimeter protection, for a company parking, for some solar power plants, usually use the simpler 5 series, 1 series cameras. But for some coastal areas, for airports, the Ultra series is much better. It's not really relatable to our Czech market, but some countries, of course, they fight with corrosion of the cameras. Coastal areas, the sea can do very bad to the cameras. So we have anti-corrosion products. So if you are going to use that in an environment that can damage the cameras, we have the certification for the corrosion, and you can see in the name the AC, which usually means anti-corrosion system. So for coastal areas or some specific installations, I think that's a very useful product. And let's get into some basics of the cameras. You can see on the video, you can see 2 lenses. Why 2 lenses? Most of the cameras, but not all, let's keep it real. Most of the cameras, they have 2 lenses. One for the thermal detection and one for optical view, which is very useful because as you will see, or you have maybe some experience already, you will see that the thermal camera, it's great for the detection, but it's not so great for our eyes, for our visual capabilities. You will not see many details of the person or the vehicle. So I think the optical part is very useful. But what it means, if we have 2 lenses, it means it takes up 2 channels. So it's very important to plan, if you are buying an NVR to record thermal cameras, to get enough channels. So be wary that 2 channels for 1 bispectral camera. But the thermal camera, it doesn't care about the environment, which is the biggest like advantage of the camera itself. It doesn't care about the night, dark, anything. But the optical camera, it of course it needs some light. So the cameras are usually they usually have IR light or warm light. So we can see by the optical lens, we need a light. So some cameras also have active deterrents. So if the perimeter trigger is triggered, it will do the lightning show, and it will notify the intruder that he's not supposed to be here. Very important is to understand the parameters, because someone who doesn't have experience with thermal cameras, they will see the resolution of the thermal lens, because the optical lens is different resolution, and the thermal lens also different resolution, much different. You can see the visible channel. You will see the resolution something like 4 megapixels, nothing out of the ordinary. But in the thermal, you will see very low resolution, sometimes bigger, sometimes lower. It depends on the price of the camera. But don't be like alarmed about this. It's we don't need as much pixels to detect a person. So even though the camera has very poor resolution, let's be real, it will detect on much bigger distance than a normal IPC camera with a visible lens. So yeah, we use the thermal lens for the detection, The visible is usually just an addition for the system, but it can also detect. There are some functions that work with the visible channel, but let's get into that later. The thermal lens also have focal length. So as a regular IPC, if you buy a thermal camera with longer focal length, it usually means, or it always means, that the distance of the function will be better. So the longer lens, the better resolution of the thermal channel means better results. Just as regular IPC, you can use this camera with the common interface that you know from normal cameras. You can connect it to an alarm system, which I think is very interesting, and we have some installations with that settings, because the thermal camera is much more reliable. Like today, the functions of human detection or vehicle detections are flawless with Dahua, I think, in my opinion. But the thermal lens are even one step closer to perfection. So obviously, if you are planning to like integrate the IPC system into alarm system, which requires a lot of reliability, the thermal cameras may be better. So alarm outputs connect to some system of alarms. Very nice addition. And now we get into the first question. So yeah, that was fast. So prepare your fingers, and the first one to answer correctly will get the prize. So take a screenshot of your answer, of your correct answer if you are the first, and send it to our email that will be in at the end of the presentation. So let's get started. So there is some like 15-second that I will have to wait for your answer because you don't see it now. There is a delay. So how many channels does a bispectral thermal camera occupy? So I'm already getting some good answers. So you will see it, so we can continue. So why would you use a thermal camera? Why not a common IPC camera with visible lens only? So there are two uses that we will discuss today. One is the perimeter protection, because it can cover longer distance, which is like insane, the difference between normal camera and the thermal camera. So long range, much less cost for installation, it's much more effective. And something that visible camera cannot do at all is fire prevention and temperature measurement. So it can measure temperature very precisely, and it can prevent fire by the temperature measurement or algorithms for smoke detection and flame detection. So some installation like settings that we can use it. So solar park, that's the most common, I think, in our experience, or I think in even your experience, if you have any with thermal cameras, the solar parks are the ideal, because solar parks need to be protected. That's the first one, and the second one, they have very clear perimeter. It's usually some very easy shape to cover with the thermal cameras. So that's the most common, but also a parking lot, very also common installation. Borders. So if there is like a necessity to cover borders with the Ultra series, the very long distance can be covered with the borders. But of course, it needs to be a country where there is visibility. So trees, of course, trees will be a problem. Hills will be a problem. We have to see the border. Or some construction site. It can be also very useful, like a moving system that you take, you use it for the construction, and you move it to a different construction when you need. It can be used like that because it's very reliable, and as you will see in the videos, it can detect something that the visible cameras cannot. It's like in very hard scenarios where people can be hiding somewhere in bushes or something, the thermal camera is performing much better. Or a farm, that's also a case where there are long fields. So what are the advantages? I would just mention some of them. I think the most important is the weather. Like when there is fog, when there is rain, when it's snowy, there is a big problem with the light reflection. When you have normal visible channel, the light of the at the night, it will reflect back to the camera, and you don't see really in the distance. With thermal cameras, the thermal camera doesn't care. So if there is fog, if there is rain, the thermal camera will see through it, and it can detect very well and reliable. So yeah, that's probably the the best factor. But of course, it's very reliable, so it can you don't need as much like petrol units or something. If it doesn't need maybe one person to confirm the alarm, it's enough, because the cameras the detection rate is much better. It's really close to perfection, as you will see. And for perimeter protection, the best use, of course, of the thermal cameras, because it covers a long distance. So you can use many visible cameras. It will cost a lot of money. Each pole for each, I don't know, 50 meters. It costs. You have to do the cables. You have to you have to build the slope, and that's a lot of money. And with the thermal cameras, which are very cost effective in this regard, you can cover a long distance for long perimeters. So the main reason is about the algorithms, and we can use less pixels for detection. But let's keep in mind this. When you open a datasheet, you know the DRI like standard. You see it on even at other brands, not Dahua. It's not Dahua specific. It's like international standard for pixel per meter measurement. So that's what we don't care about right now. So if you open datasheet and you see this, and you see identification, recognition, yeah, you're like confused about this. It's not what we are capable of. You have to search for the IVS distance or fire prevention distance or thermal measurement. I don't know. I'm not exactly sure how we are calling that in the datasheet. But you don't care about the DRI or DORI distances. You care about the IVS distance or whatever we put. Like it's related to our algorithms. So it's usually better, and use that. So yeah. So the top table, it's what you are looking for in the datasheet. If you open normal thermal camera, you will see the IVS distance. If you open with the T at the end, the thermal camera for measurement of temperature, you will see the temperature distance there. So that's it. And let's play some video. Let's see what we are able to do. So filtering false alarms, of course, with animals and other stuff. And this is what a thermal camera looks like. So for some of you, maybe this is your first time seeing the performance of thermal camera. You see how the animals are filtered, and we improve the algorithms continuously. So maybe in the past, like maybe 5 years ago, maybe there sometimes an animal could cause some problems, but not anymore. I think we have improved the algorithms to perfection now, and we will see more reasons later. So animals should not be a problem. Of course, it's better if there are no animals. All kinds of animals, all kinds of common animals, and even animals like in general, but we are focusing on some specific animals that are occurring in our environment, but also in Asia environment. So I don't think we have tigers and monkeys in Europe, but we also focus on that. Yeah, and you can see here is the great video of a regular camera or the visible channel of the thermal camera, and even human eye. I think on the left you don't see much, but with the thermal cameras you see something that just the human eyes will not see. Yeah, there is the smart linkage. Yeah, and you see on the top video there is the active deterrence functions that some of the cameras have. Not all of the cameras, some of them. And you can see the smoke. If the smoke is not too thick, like from a fire, like if there is a fire, let's be real, you don't need IVS detection. So if there is a fire, you don't really care about if someone is like intruding your home. You usually care about the fire. But for like normal smoke, not like a house burning, you see that the thermal camera is seeing just perfectly fine through it. And even a little dent. And you can imagine how it performs in fog, outside environment. So we have a function with our cameras, we call it dual rule combination. It's about well, as it sounds, to be triggered, to the functions to be triggered, it needs two rules to be broken. So the person, and you will see in the video, it's most obvious. The person triggers one, and as soon as it triggers the second rule, it will trigger an alarm. So yeah, it needs two rules to be broken. So it's usually for like more precise alarm. So I think that's an interesting function you can use. You can also set an IVS rules sensitivity. So it's usually used. This function is usually used for distant objects. So yeah, and we also work with something that's called like visual, like image size normalization. So it works with the object as it gets in distance. It will like in proportion to the distance, it will calculate the approximate size of the target. So it will the IVS functions will work better. So the camera will see that there is like a distance, and it will calculate the approximate size of the object that it's supposed to be in the distance. So the human very close will be, of course, bigger, and in the distance they will be smaller. So that's what image size normalization work, and it's of course again to perform better in the filtering of false alarms. And well, let's get to question 2. So who paid attention in the previous 3 minutes? You have a great chance to win the second camera. So prepare your fingers again, and let's get to it. Because there is a 15-second delay, I will leave it like so, and I will continue. So let's see. When I get the first correct answer, I will continue. But remember, there is 15-second delay. I don't see it immediately. And I get the first question, for the answer correctly. So let's get to it. So you may heard about Xinghan. It's our AI model. It's for the normal visual camera. It's been promoted very well, and it's a revolutionary function. I wouldn't call it, maybe like algorithm improvement, and we'll see it in our thermal cameras as well. It's to improve the distance. It's for much better detection of humans, vehicles, animals. And now our regular cameras. It's not about discerning what's discerning about, but regular cameras, you may notice that there has been big improvement in distances of IVS functions, and this of course may confuse you now. Why would I need thermal cameras, and now I have the visual cameras that have a long distance? But we improve the thermal cameras also. So you can see some models already on our website. They should be available for purchase. The V1, the V letter and 1 at the end, they are the new improved models, and there have been many improvements, but I would call the bigger improvement the Xinghan models. So you can see the IVS distance up to 85% improvement. So that's a big number. That's a big number. So you see with the cameras with the lowest focal length, and the distance have improved very, very much. So I think that's the most interesting thing about the cameras. But we improved we improved the lights, we improved the audio systems, the housing. Now it's how to say, it's not easy to break. We have the IK10 housing, and we improved many of the algorithms for filtering also false alarms about thermal cameras, about the thermal functions. We will thermal functions for temperature measurement, but we will get into that later. So you can see also this was the first series. So this small camera, it will be a little different. This is the old model, but the new model, there will be improvements, and also the 5 series camera, but not only these ones. Also the PTZ cameras that we will talk about later, there also has been a big improvement in the distance. So yeah, so 5 series cameras, they can now detect a human up to 500 meters. 500 meters, that's a long distance for such a small camera. Of course, we have the positioning systems. I don't have it here, but the positioning system, the smaller ones, the bigger ones, or the really big ones that we will talk about, they are for thousands of meters for detection. But this small camera with the correct lens, of course, the focal length has to be the longest model, but 500 meters. So that's a big one. The visible channel can have varifocal lens. So that's good. We have model with 50 millimeter. As you can see on the bottom left, 50 millimeter focal length. So that's for the thermal lens, and that means the longest distance. So you see the V1 at the end, and you can be sure. But also there has been some improvement in the visible, in the thermal lens, but the visual part. It's better. You will see it in some of the examples that the colors, it's more sensitive. The colors are better. Yeah, and this is an example because I was talking about the bispectral cameras with the 2 lens, but we also have the cameras with only 1 lens. So only the thermal lens. So you see only the one lens in the body, and also there have been the same improvement like I talked before, but it's the camera that doesn't have the visible lens, and you see many algorithm upgrades. I think, as I said, near perfection, I would call it. So PTZ cameras. We also have. I couldn't put it on the table. Here it is. So something like this. We have a thermal PTZ camera, and we have improved that a lot. Who's familiar with Shinhan models? I will put it here. You know something about you know the term vis tracking. It improves the auto tracking functions a lot. So we put it also in the thermal cameras. So the auto tracking, as you can see in the videos, sorry, you see it in the videos, the auto tracking functions. It will detect the human, it will detect a vehicle in the second video, and it will track the vehicle automatically. So that's a function we improved a lot lately, and you can use that in thermal cameras. So for perimeter functions with the auto tracking function, a big improvement. For some very specific scenarios, of course, in Czechia, no way we can use this, but maybe in your country there is a market for this. If you use a radar, you can use it to linkage boat tracking. So the camera can automatically track a boat. But there are other cameras, for example, from the Ultra series that have boat tracking and very long lens that you will see in the videos. It's awesome. Yeah. The best choice for perimeter protection, as I said, the most common use I think we use is the solar plant, because there is a lot of expensive equipment. It's easy to steal, I guess, and the perimeters are very easy to protect, because they usually remove the trees, because it covers the solar panels. It's usually on some flat ground, so very easy, and you will save a lot of money because the visual cameras are just not as performative, and it's also easier for like the infrastructure. From the cabling, you use some ring topology with the switches, but you don't have to use as much. Sometimes with visual cameras, it's usually not even possible to do such a huge, like to use like 100 points across the whole perimeter. So yeah, so please consider when covering a solar plant, always thermal cameras. So, and we move to question 3. This one will be very tricky. It will require your utmost attention. So you will see. Who knows the percentage increase in IBS detection with Shinhan large-scale models? So how many percent? It was mentioned there. So how many percent the improvement was? Do you know? So there is again 15 second delay. I don't see the answers yet, but I will wait for the first correct answer. Nice. You pay attention. That's a good sign. It was hidden. I only mentioned it maybe once or twice. So good job. So let's get into Ultra series. So like the flagship of our portfolio is this camera. It's huge. It's maybe as huge as me. It's like this. It's a huge camera. So you will see you see this camera. It's the use is for very long distance. Like it has the optical spectrum. You see it's for up to 10 kilometers of detection, and it has the highest protection level of anti-corrosion, of how do I say it, breaking. It's not easy to damage. It has a cooler because it's a very performative camera, and you see the lens up to 1100 millimeters. So this is the camera that you could use for like huge cities, airports, some coastal areas for the boat detection maybe. It has block alarm, so if it's blocked for any reason, from some mechanical reason that it cannot move, because it's of course it moves around, it will do an alarm. It has smart wiper. Some of the cameras you maybe saw the wiper on the PTZ cameras I got here. So a wiper is not something that's uncommon within our portfolio, but of course it has a smart wiper. Optical port, that's important because there will be just a very long distance. You will not cover it if with a regular cable probably, so with metallic cable. So yeah, there is need for optical port, and of course you can remotely control it. So this is the performance. You see the laser. It's for the visual lens, and you see the performance on laser. 700 meters. Yeah, you see this is the video I talked about. This is how close you can get to something. You can just imagine the performance of the lens that's showed here. That's not all. Also, this is how you get it. Boat tracking, that's something I talk about. It's the function that can automatically track a boat, which is very useful for this camera. It's not a cheap one, but for the performance you get. And you see also here the laser. It's self-adjusting. So maybe you have seen already some of the high-end cameras. They perform just like this. So it's not only this camera that's this impressive, but yeah. So, and we have like this positioning system. A positioning system is something usually you put it in position, and usually it can rotate, it can tilt. So this is the camera. It's with GPS. It's a ranger finder with, of course, with a very performative thermal lens and visible lens, of course, smart wiper. So this is something that you would use for, of course, also long distances. It's something that's more like the first camera. It was an overkill for most installations. It's really for like very specific, like the coastal areas, the airports, something very performance demanding. And this is something like a middle ground. It got optical stabilization. It's got a very big lens, very long, the focal length, and you see the thermal resolution, because we have customizable like the HD resolution. So we are getting close to normal visible cameras. So we started at very low resolution, something like 256 by something. I don't remember now exactly. It was the lowest end, and now we are getting somewhere. But this is because the performance of the visual, like of the detection of humans, is much bigger. This is like for some maybe cities, maybe some bigger areas, maybe smaller airports, stuff like that. And you see, as I talked about, the improvement of the image. So maybe you thought that the thermal cameras will be perfect in this regard, but they can be even more perfect. So we used for the new series, for the whole new series of cameras that I talked before, and for this camera also, better sensor. So it's more sensitive, so you can see clearer the difference. So I don't think I have to like describe it anymore. You see the difference. The left image much darker, not very visible, the important stuff. So that's an improvement. Yeah, and this is a very interesting one. This is like all-in-one solution PTZ camera. It has everything you would need for best performance. So obviously it's a thermal camera that's rotatable. There is optical camera, the PTZ part, and you may ask what's on the left. From your point of view, on the left, it's another camera. No, it's a high power speaker. So it's very powerful speaker. So maybe for some larger areas that we have to so that are like there may be some intruders that we want to deter away. So the normal speaker that we use it's good for tens of meters, but this will do good for hundreds of meters maybe. Oh, I even mentioned it in the presentation. I see 200 meters. So I think this is a very interesting product. So it combines a lot of functions that we may use. Yeah, of course the auto tracking. So the auto tracking function, but that's something that the PTZ cameras will want. So yeah, this is, you see the linkage. You saw the thermal camera will detect the person, and the optical PTZ camera will take over. So you can see it, even our normal cameras, not the thermal cameras, they have this function now. So for example, when there is like the wide panoramic image, it will detect a person and the PTZ camera will take over. So this is something that wasn't possible years ago, but it's possible now, and it's very, very well functioning. Yeah. So that was about perimeter protection. Let's get into thermography. I have to speed it up a little bit, maybe. So the best use to measure temperature. Gas station. Of course, gas station, there can be fire very easily. But now there is a lot of electronic or e-vehicles, like the charge with electricity. So there are much more pain points in the gas station industry. So we don't want our vehicles to overheat, the electric vehicles. So that's a big one. Parking lots, of course, again, electric vehicles or even gas vehicles, they can catch fire. Very important. Waste and recycling. This is maybe the most used scenario I have experience with the waste management, like the landfill. It will measure a big chunk of the landfill, and when there is a danger of fire, it will notify you because the temperature measurement. So landfills, very, very useful. Forest fire detection, we have algorithms for forest fire. There have been some installations I will mention in the success cases. And petrochemical industry, so also it's a very dangerous place for fire to be in. And why the thermal camera is the best solution for this? So you have many solutions. You have maybe the worst one, like when there are firefighters already, it's too late. Sprinklers, they can extinguish the fire, but the fire is already in progress. Not a good one. Cameras with flame detection. We have these products, but it's not the best option because flame detection, it requires flame to be in the scene. We don't want flame. Smoke detector, we don't want smoke either. It's better to catch it when it's smoking before it's flaming hot, but not the best thing. Yeah, and some more like precise detectors that detect the smoke particles, but it's already smoking. We don't want that. So thermal cameras is the best option. You measure the temperature and you catch it before it's too late. And again, this is the data sheet of V1 thermal camera. Is the new one. Is with the T at the end. So the T means it's for the temperature measurement. So what's important very important to mention. The bigger the object we want to detect, for example, landfill, very big object, the area that may become hot, it's very big, like 2 meters by 2 meters. It will not be one small point that will become hot when something is not going right. So it's very important to pay attention to the datasheet. You see the small object, the 0.1 by 0.1 meter, has like 1/10 of the distance, the minimum distance, compared to 1 meter by 1 meter. It's the cheapest camera, the shortest focal length. So this is the smallest distance we can get. But it's important. Don't just look in the data sheet, see the distance, and be disappointed. If you are going to measure a big object, there will be much bigger distance. Important. So yeah, gas stations, and importantly, gas stations including EV chargers. That's now becoming a big thing here. So we don't want that. We don't want that to catch fire, right? So parking lots, of course, we have vehicles that can catch fire. We don't want that. Waste factories, again, there is a big risk. It will happen eventually. There will be some kind of waste that will react not so good together, and it can cause a big fire and pollution of the air. Not good. We want to prevent that. And you see how it works. So you see the video. This is the thermal camera. It can measure the temperature, and you see the temperature measurement. It will catch. And this is the visual camera. In the visual camera, you don't see anything really. You see some smoke, but you don't really see it. You wouldn't notice it. But the thermal camera, it will see just right. So there are like 2 temperature ranges that we can set up. So it's -20 up to 150, or 100 to 550. It's not really that the camera wouldn't measure it, like it wouldn't detect if there is something 600 Celsius. It's about the precision. So if we want to have the precision of the +/-2 Celsius degrees, which is important to know. Yeah, so it's usually in the data sheet, but +/-2 point Celsius or above in the bigger temperature, it's +/-2%. But you can see it's very precise. You need to you need to be within the distance that's in the data sheet. So keep in mind the data sheet, like the scenario of the size and the distance, it has to be correct in order to get the correct results. So if the distance is longer, there can be like bigger deviation. Yeah, so the deviation with the correct settings is +/-2, and we can measure many rules at once. So we can measure. I can measure that window and this thing and that box. I can measure it all at once, and I can do it like that. I can do a point, so I can point the certain things. I can do a line, yeah, that I can measure rectangle, so I can draw some rectangle, polygon, some very random shape, or ellipse. So I can measure the temperature at one point, at one specific point, or just like that. And there can be 4 strategies that can raise the alarm. So it's the global hot and cold. So if there is something below or something above a certain degrees. So I said it. This point, it can be only 50 Celsius. This point, it can be 100 Celsius. And when it goes above or below or something, it will cause an alarm. There can be also something we call pre-alarm, which means there will be different kind of linkage when this is like 30 degrees, it's maybe okay, but it will notify me. And when there is 50 degrees, it will go all out. It will raise the sprinklers, and this is something that we call pre-alarm. It's like a little notification in advance, so we don't raise the full alarm. Yeah. So of course, the threshold, something is bigger, something is smaller within the certain point, or something equals. Slope alarm, if there is like too much of an increase in certain period of time. So if this object it gets much hotter in a few seconds or few minutes, there will be alarm, or comparison alarm. So it will compare certain objects, certain areas. Yeah. So yeah, this is the distance, but you will see in the data sheet. You don't have to learn it. It will not be the question. I will not ask about the distance. You will always see the distances in data sheet. We have to learn to use them. Now you may ask, because in certain areas like the landfill, there will be cars moving. So there will be like the engineering trucks that move the landfill across. So they are hot. They are hot. They have the hot exhaust. Exhausts are very hot. Hot things on the cars. It will cause an alarm. No, it will not, because we have algorithms that reduce the false alarms. So this is something that even humans can trigger. You will see human trigger, because there is 30 degrees threshold, so it will cause an alarm. But we have the algorithms for the visual thing. So the visual part of camera, it will prevent this from happening. I'll just stop that. So you will see, yeah, the visual part of the camera. You just turn on the false alarm filter for these, and it will be triggered only by what we want, not by the trucks, not by people, because sometimes the temperature that we want to measure is lower than the body temperature. So even humans can cause an alarm, and we don't want that. So that's why we are constantly improving the false alarm filter. And it's not only for these targets, for the trucks, for the humans that move around the area. It's also for reflection. Reflection is a big problem with thermal cameras. Like not a problem we haven't solved now. We have reflection filter for a long time, but in the past, years ago, it could be a problem, because reflection from glass, from water, it could cause problems. So I will still recommend you to like not include any kinds of reflections in the image. So if you can prevent that, if you can prevent some reflections of the sun, the most common thing, try that. But we have a filter for it, so it can be like removed, the alarms, but it's the best thing. Like you don't have to detect the temperature or where there is reflection. So you can just the polygon, you can draw it outside of the reflection. Yeah, so this is the common occurrence, the forklift or some engineering truck that will cause, yeah, this is very common, the landfills, the waste management, some warehouses, the forklift will also be a big problem. Again, the truck in the landfills. Yeah, the visible camera, it will detect, as you can see on the left. You don't see my mouse, but you have to imagine it. On the visible channel detects the engineering vehicle, and it will prevent. And now, this is also not so easy question, but maybe easier than the previous one. So I'm thrilled to see if someone remembers. What's the approximate temperature measurement deviation of our products? So it's like the plus minus something. You can just use the one of the examples that I have these. So there are two correct answers. So you can use either one. and I will wait for the first correct answer because there is the delay. And my colleagues in the chat, they will like pick the winner. The first one is not the correct one. It's the deviation. It's plus minus something. Still no correct answer. So I will assume that there will be correct answer, but it's not here yet. So I will just continue with the presentation. So forest fire and explosion prevention. It's something that we can use in forestry to detect forest fires. As you saw, we have like we can cover kilometers of distances. Oil rigs, very useful. Some bigger factories or power plants. Yeah, power plants is an important thing. So for the intelligent forest fire prevention, it works like that. It works with the upper end of the cameras, and the better camera you use, the more distance you can cover. So you can then include it in your VMS system, and you can get results. So for example, heat detection, it works like that. It's on the thermal channel. It will detect if there is something hot in the distance. Yeah, so you see you saw the camera catching the hot object. So it's very useful for very long distances. And you saw the PTZ camera; it was movable, so it moves around. It sees the hot object in the distance, and it can cause an alarm, and you can just zoom it in, and you can confirm the alarm. It's very useful now. The summer is coming. Here in Czechia, we already had a big forest fire some weeks ago in a national park. So maybe they could use that there, and it could prevent it in the future. I really think so, because there's a good environment for that. And the visual camera, the visual part of the camera, it's for the smoke detection. So where there is smoke, and we will see some more detailed video in the next part. So the visual camera, it scans the landscape, and it can detect smoke. That's a big distance. So the first one, it's the function of the thermal lens. It's much more obvious, but this is a visual algorithm. And you see it here in action. It's something that a human eye maybe would not notice if you have a lot of cameras around. The zoom is quite impressive. Yeah, so this is the visual part of the camera it will detect. Because where there is fire, we need thermal cameras, and sometimes the explosion-proof series can prove to be a useful one. So we have explosion-proof cameras, certified explosion-proof cameras that we can use in many environments for some power plants, oil rigs, some factories with explosives. There is a big necessity for explosion-proof cameras. So we have these in stock, and they are with the thermal lens or even the optical lens. So they combine. We have the single lens with almost only thermal, or the big spectral with both. So the common scenarios, some gas leakage. If there is explosion, you will not get any just with regular camera it will disappear as soon as the explosion begins. Yeah, so You can imagine the scenarios. Just scenarios where there is a big risk of explosion. And what's also interesting, and this is something that not many people know, it's these macro cameras. Macro cameras, we call it, it's for close distance. We have it in visual, so maybe it's good to consider it when you want to, for very close distance, you want to see something. It's usually used for some measuring devices for remote like visual connection. But we have it in thermography. So we have this thermal macro camera, and it's again, it's for close distance, very precise, and you use it in server rooms. You use it for some factories on some machines, and it's quite cheap. It's easy to install, and it's for close distance. So it can also provide the visible lens, so you see what's happening. You see some numbers maybe on the machine, but you also get the thermal result. So that's the macro camera. It's not very known, so please consider this for close distance, for several rooms, for something like this. And this is like something that you can be creative in answering this question. So it's about the important factors when considering distance in thermal measurement. So what you are looking for in the parameters of the camera, or what you can like the object. It has to have certain like measurements. Maybe you be creative in this. So what defines the distance that we can detect the temperature? Yeah, correct. The object size. The object size is the correct one. So I will not read your username. It's too long. Sorry. But the object size, it's the correct answer. That's what I wanted to hear. But you could be creative in this. I would also accept like the parameters of the camera, the lens, the focal length, or the resolution. The resolution of the matters also. This is something that I was not planned to talk about at first, but this is something I think it deserves to be mentioned. It's our Tools designer. It's a very important like it's not a software. It's more like an application. It's a web-based application, and you could just Google it. Just Google Tools designer. You don't have to search on our website. And it's very useful. You see how it functions. You will put a map or a plan on the background. You will put distance. You know that from one point to the second point it's 100 meters, for example. So you will tell the application that this is 100 meters, and then you just pick the cameras and you put them in the tool. So you see. The cameras is just a random installation. I wanted to share a real installation because we are working with this software a lot, but I just maybe it's not good for the customers. You know, it's their installation. They wouldn't want it to see it on the internet. It's for security after all. So I just made this random installation. It's not nothing you can learn from, but it's to see how it works. So it will show you the distance, the performance of the IVS or thermal function. So you just put the camera in the map, and based on the distance that you put first, you will see the solid orange. The solid orange part is where it can detect, for example, human. You choose the function. If I choose vehicle, the orange part will be much longer because we can detect vehicles for longer distance. So you see it like the blue one is optical. So this is the bispectral camera, So the blue one is optical, the orange one is the thermal part of the camera, and the solid orange is the solid orange is the IBS distance. So this is how you can very easily configure your project. So you choose the cameras, you choose certain cameras with certain focal length based on your needs, and you just put it in the map, and you can draw walls that will cover the parts of the. So if you see the like what the camera sees on the map, and you draw a wall, it will reduce because it will consider the wall correctly. So very, very important. Just try it. Just try it. Play around with it. It's very useful. It's not only for thermal cameras. It's very useful for normal cameras too. So very useful, great tool, and we have it for free on our website. Very useful. I recommend 100%. So let's see some success cases for the end. So in Germany, we have many success cases. This is just like all over the Europe that we could show you, but we have many, even here in Czechia, many projects. Some we can share, some we cannot. But this is something that we'd like to share with you. So Germany, 4 stores, perimeter protection, very common. Britain, solar farm, that's very common also, covering perimeter. Waste recycling, fire prevention, also great use of thermal cameras. Korea, EV charging, obvious. We don't want them to overheat. Parking lot fire prevention, as obvious. Rail haulage, perimeter protection. We don't want people to get on the rails. It's dangerous, and they cause problems there. So in Czechia, OIMV gas stations. Norway, also gas stations, including EV charging. So that's about it. And then for forest fire and explosion prevention, Bulgaria, forest fire prevention, Greece, explosion prevention, some thermal power plant, probably not the best to tell the location. Hungary, chemical factory. So a lot of installation. You guys, you are from various countries. I bet you have a lot of our installation in there. This is just some of the best we can show you. So that's about it. So before I switch back, I just want to say thank you for your attention and for your for the questions for the answers that you gave to my questions. So I think we will keep this online, so you can play it later. And so I just want to say thank you and have a nice day. Thank you for your attention, and I will switch back to the final slide that you can scan the points. You can scan in your DH Partner app. I recommend you scan the points, you can scan the serial numbers of the cameras, you scan this QR code, you get points and you transfer them for some prizes. It varies by the country. We have different prizes probably than you. So it depends on your country, but you can scan and get prizes. Scan serial numbers of all the Dahua. Oh, I crashed it. But it will survive. Scan the serial numbers, you get points, and that's it. The winners, please send the screenshots. And your contact details to following email. And I thank you. I will leave it online for a bit, and have a nice day, and see you probably some next time.